Okay, hello everybody. Hi, this is Mark here. And if you could please tell me if you can all hear me well. You should be able to answer on the chat. Okay, that's wonderful. Thanks. So good morning, at least it's good morning for me. And welcome to the webinar. I will share my screen and we will start. There you are. Okay, and to make it real simple, I will just start the complete screen share, the complete desktop. Now let me check that I can see the chat. Okay, that I can see the Q&A. Okay, and I have my assistant and she will help me if I miss any one of you, that you're saying something and I'm missing. So we're good to go. Here's what I want of you guys. I want you to ask questions. I want to participate. I want you to be active. Otherwise, I'm just one guy talking and that is not fun, right? So I'll open my slide decks. I'll tell you what I want to talk about. But please, please prepare something for all of us, because that's more of a workshop. It's not that just that I tell you something. I'll tell you a story, yes, but you will tell me your stories in return. So let me start by doing the slideshow. And I tell you where that came from. That was one guy, one professor at the university that got in touch and he said, well, I'm working on AI for cybersecurity. So I told him, but cybersecurity is the prime user of AI. They were there first. And he said, no, not exactly quite. He said that he is at the University of San Diego. And if you know, San Diego is just a wonderful place. So I immediately envied him a lot. So he's a professor there at the university. And there is such a qualification that the universities can get. It says, we are the center of excellence for some specific purpose. For example, in his case, we are the center of excellence for cybersecurity. So that university, University of San Diego, does not have that yet. That's why they invited him to help him organize how it will be, and they want to be a center of excellence. But it turned out that it's not all that glorious as I thought. There is a committee, there is a yearly conference where they all universities present, and that's where the government gives them this accreditation. And he did it for a couple of universities already. Now he's in the third one, but it's a long story. So let us start with what I prepared him. I will also tell you what he shared with me, and that is a good beginning. So a kind of a workshop. I made it in the form of our actual class. That's what you would see in class if you were to take that class, but I'm just talking about this, using this as a starting point. So people who would be interested in this would be people who know something about coding. It would also be people that are interested in cybersecurity. And it would be people who I hope will be asking questions or giving their own stories. So sometimes after all is said and done and people just don't know where to start, where to click, this guy. So we help you, we do the labs. That explains that if you just listen to the guy like this, well, that is a limited impact. But if you push the buttons and if you make that plane go down and up, then you really remember what it is. And then you'll be able to do a lot of interesting things. Now, usually in class, I also ask you about who you are, what your goals are. But in here, what I want to do is just to give you my picture of how I understand it, and you please correct it. So there is a wonderful video on YouTube. If you want to listen to that video, it's a guy who goes by the handle of Greg Q. And that's quite unique. So he talks about how can you be a good hacker, or he puts it as a freedom fighter, and nevertheless never get caught, not by state and not by other malicious people. He talks about how you create a persona. Persona is something that is completely imaginary, and sometimes it takes just a few hours if you have a lot of tools, but really it takes at least 2 weeks to work on a persona so that it looks real, but has no connection with the real you. Absolutely none. Never go from the same IP. Never use any of the same, whatever it is that you are. So listen to that lecture and get a feel that anybody can become a hacker. So it's essentially a whole world against you. Now, on your side, we'll talk about exactly what we can bring on our side. But if you read about what's going on, you will see that the crime is very well organized, and it's organized not because they're all good guys and value cooperation, which it turns out to be, yes, but it's because this is efficient. They have marketplaces. For example, if you want to buy credit cards, that's one marketplace. If you want to sell them, it's the same. If you want to do the drop-off points where you receive these goods, that could be a completely different group. Then they all use escrow services so that transactions is trustworthy. Once the two sides do what they do, then the third party releases the payment. They all use Bitcoin. Very useful, nothing can be traced unless you go and buy some coffee with your Bitcoin account in a shop. Then be very careful about that. They also have even vouchers and gift cards. So that is a very well organized and efficient system. Okay. And there is little that you can do about this. Yes, there are government agencies. Yes, there is ABI, but they're interested in the bigger cases, and it takes them an enormous amount of time to help, because they're limited by all kinds of laws that you need to catch the guy, you need to catch the guy in action, and so on. So it's really up to you. And up to you, meaning that you can either hire protection. So it does look exactly like mafia. Recently, there was an interesting, I think BBC was doing a program, which essentially said exactly this. It said, guys, you're all done in. That is a fact. Now, if you create a higher wall to jump, well, then you will get better protection, or you buy that wall. So that is exactly how mafia operates. But unfortunately, that's the case. And you may do this, you may create your own teams, your red team, your blue team. What's the difference between the red team and blue? Red team, everything is allowed. Blue is much more careful. So that all is true until we go and we come to this cartoon, which explains that there is AI. So the cartoon talks about that our poor programmers just begin to figure out what to do against those hackers. But one of the advantages that they have, our programmers, is the AI. And that advantage is this: you guys have all the data. If you're on the defense side, you have a lot of data from all of the attackers. So theoretically, at least, you can get all of the protection in one place. And then if you can apply AI, then, well, maybe that is your definitive advantage. It's not to say that hackers are stupid and they don't apply AI, well, but nobody attacks them, so at least not that many. So we don't get, they don't get all of the information the way we can get. All right, let's assume we do get all the information. How can we act on it next? How can we apply machine learning? That, by the way, is the picture of machine learning. So machine learning, first of all, is this. Machine learning says, don't try to create the rules. Try to give the computer all of the data and let it figure it out on your own. This idea of giving the computer all the rules, that was quite popular in the early days. It was called rule-based engine. And what I would do is I would figure out what are the common hacks. It's this old approach where you tell somebody, well, explain how you do your hacking, and I will codify it, and I'll give you a bonus if you explain this and all of that old stuff. But today you just give all the data to the computer, like if you're teaching a self-driving car. Then you would record your actions, you would record what the outside world shows you, and you let the computer figure that out. So that's the new idea. That is the guy who formulated in nice terms how you do this, and he was explaining it in terms of, let's say, a dialog system. You create a dialog system, then there are three letters that we need to know. One is experience or the data. T is the task. You need to say, what do you want? For example, I want to find unusual activity. That will signify hackers, potentially. Or in this case, talk like a human. And P, the measure, the probability that the program will convince you that it is a human. That's a must. If we do not have the measure of is it good or is it not, then we're still based on our gut feel. So let's say we do all of that. And we have the performance measure. For example, how many hackers did we stop and how many hackers did the previous algorithm stop? And we can replay it against new algorithm with the old data. And then your data, your experience, which you can put in many different shapes. It's usually a lot of data. You can put it into some storage like Hadoop or a cloud storage. And then finally your model, the model which will tell you that guy is bad, or at least that guy is more suspicious than the other guy. So in these terms, you will find out that you will also need to know linear algebra, but not to a large extent. Here, I explained how you take all the parameters. That would be for a simple kind of hello world application for AI, which is not even AI at this point. It's just going there, and how you can represent every, let us say, house by a number. Let us say how many foot, square feet, number of bedrooms, and so on. So then each house becomes a vector. Well, each house is much more complex than the vector. It has a story. But for now, let us say each house is a vector, and altogether all those houses are a matrix. Well, and that is a linear algebra. There's not all that much that you need to remember from linear algebra, other than that you can multiply vectors and you can multiply matrices. And of course, you can multiply, let's say, matrix by a vector. Well, it turns out that most of the AI is formulated in this. The little difference is that that's still linear algebra until you bring in the features. How did I know that the house is characterized by square feet, number of bedrooms, number of bathrooms? Well, that was my best guess. It worked before. But today people try to give the computer the picture of the house and whatever they can get about this house, and let it figure out what the features will be. Maybe it will be the height of the house. You don't know up front. Maybe it will be what people say about the house. So altogether, when you do this, this is called feature engineering. And again, initially feature engineering is done manually, but then later on it is done by the computer. That's where the AI comes in. AI is automating our reasoning, automating whatever humans can do very well. So AI has a long history of ups and downs. People like to say history of over-promising and under-delivering. Except I would say for today, that revolution started in about, let us say maybe 2012. And 7 years later, AI is just as popular. It has not become a bad word like it did in the 80s. And these links, if you ever want to open them, that will show you the example of the very first application done on the old approach. So since I'm sharing the screen anyway, I can do it very easily. Okay, do you want to attend my webinar? And she says, we were discussing you, not me. Okay, I am sad you don't talk to me. And she says, how long have you been said that I don't talk to you? All right, that's the old approach based on rules, and it's very limited in what it can do. Now, the new approach is based on neural networks, and it's something like this. right? So where's my quick draw? Don't think that's right. It's Google Quick Draw game. So that's the one, right? And what you do here is, let's draw. It says draw a mountain. Okay, so let me try to draw a mountain. I'm an extremely bad. Wow, got it. Unbelievable, right? So how does that work? Well, this works with a neural network where they train for a few possible answers. You saw that it says draw mountain, draw stairs. It doesn't let me paint anything I want, but it has a classifier behind it. And that classifier is neural network. And it can distinguish between a mountain and a stairs. And then later on, let's say I do something real quick. Okay, could we, I'm finishing it up in a few seconds. Okay, good game. Later on, I'll show you how does it work. Okay, so that's where things are, and that's what gives us hope as a protection against hackers. And this explains how things changed, that it used to be that this green line that shows our regular standard approaches, like house price prediction. That was the standard algorithms. They reasonably improve with the size of the data, but they never go too far. There is a limitation in them in that they're using a formula, and it's only so much that the formula can give you. Now, the neural networks, they combine, you can think of combining many formulas or many neurons. In other words, it can figure out every little variation in the data. And what happened is that when people got more computing power, then the neural networks began to shine. And that's where we are. That's the neural networks. Neural networks are the basis of today AI. It's almost a synonym today, AI and neural networks. There shouldn't be. AI will go forward. It will use other kinds of tools. And today, these other kinds of tools are all shown here. There is a neural network here as shown as completely connected neural network or DNN. And then there is also a special kind of neural network for images. And then a special kind of neural network for time series, for predicting what will happen in the future. By the way, we will use exactly this RNN, which I will show you later. So that's what happened. People started using neural networks, and neural networks are able to help you to figure out the features themselves. From then on, your learning becomes much more precise. That's what I'm going to show. And that's where I would do the show. But before we go, no, I think it's a good time for the show. So what I will show you is this. I will show you some of our labs. That's right here. We created a few labs. And the very first lab is about house pricing. Now, how do I show those labs? I can show you what's in the browser, and it's a IPYNB extension. So that is Python notebook. But to run that, I need to do something else. I'm right there in my terminal. I'm right at those labs. And what I need to do is I need to say Jupyter notebook. I could also say Jupyter Lab. That would be the newer version. So now these are these same labs, but they're shown to me in the browser. You can see it's localhost. I'm pointing to my own data. And you can also see that it is 8888, familiar to those people who like to run Jupyter. So the first lab that I want to show, and I do apologize for being quite fast, that's a must, but please ask the questions. Let's see if I don't see any questions as yet, but if you do, then eventually I'll find them out. Maybe at the very end, I'll look at all the questions. That would make sense. But please start asking right away. So that would be a standard approach. In the standard approach, what I do, and by the way, I can either click on run like this and make that code run, or I can hit Shift Enter, and that you will not see, but it will work. So what we do in this lab is a standard machine learning application, house price prediction. Now, that's not what I really want to show. I want to show that's what it was, but what will be, I'll show you later. However, that shows you the power of what is called a Jupyter Notebook. What you're looking at is a Jupyter Notebook. It allows you to add your text, your explanations. So for example, I can double click on this white and I can say, this is a webinar. And then I will click on run. And this is a webinar will show up very nicely, right? And if I made a mistake, I can double click again and I can say explained. And then I can run it again. I'm hitting Shift Enter. It's just faster this way. There it is. So this is a Jupyter Notebook that combines the text with the code. And how do I know it's code? Because it's gray. Because right here it says it is code as opposed to markdown, which would mean text. And I can run it. If I run this, then it just runs. In this case, I'm importing some packages that I will need. But the next step right here, you see the star. The star meant I'm still working. It downloaded the data. It said, well, show me the data. So we're showing the data. And then we'll continue with this lab. That is an example of an interesting study that one of my students did. And what was allowed is everything. So he starts with the regular methods, but then he investigates the data. Let's go look at his investigation a little bit. So he looks at the data, figures out what would be the best coefficients, and he doesn't like the quality. Okay. So what he does then is, let's predict the prices and let's show the data. Obviously the quality wasn't perfect. And then he says, oh, okay, that's very interesting. Let's show the number of bedrooms versus the price. So obviously that is some kind of not a very expensive area of the United States. I think it is Oregon. But an interesting thing that he noticed was that we see a house seemingly with 33 bedrooms. And that house costs 600,000. Well, that data, it turns out, kills all the results because we use the method that is sensitive to errors. And this is what it did. And then if you plot it like this, it's bedrooms against sales price, you see that's a huge outlier. Well, that method that we use called linear regression, it is multiplying errors. Once you started doing errors, it gets even worse because we minimize the total of the all squares of the errors. And so that point really kills us. So he filters the data. All of that will come later. I'll show you why it will be important. So our next step here is to look at other labs that I have prepared for you. And the other lab is DGA. So what DGA is, okay, it is an investigation of whether the website is fraudulent or no. You know that hackers like to direct you to the porn sites, and that the call it keepers of public morality try to stop that. So those sites are registered randomly with some random names. What we're trying to get to is that name that I just saw, like BMSK, that's obviously a strange name. Besides, it ends up in RU for Russia. So to me, that looks like a fraudulent site, or at least it's something that's generated not for a legitimate reason. As a Hollywood reporter, that's probably good. But can the computer decide it on a much better basis? Well, it turns out that yes, it can. So we use all of that data. And then we are trying to figure out, can we predict that that site is indeed fraudulent? So that what I'm showing you right now is the basis of the investigation. And with the get, we'll get to 86% precision. There you are, 77% precision. Okay, so not bad, but not perfect either. What I really want to show you is this. I want to show you the the neural network. Now, what kind of a neural network? In this case, we're using a RNN, so the recurrent neural network. And what it does is understands the sequences. It understands history. Now, how can you understand history? Usually you take a formula and apply it. There is no history to that. What the RNN trick does is to take the previous data and make it input into the new data. So your old history becomes your input. And once that is your input, you will be able to predict things much better. So in this case, if we run through that lab and we're trying to predict is that a fraudulent website or no, we'll get much better precision. Let's see if I already did. I ran at that lab for you guys because that step, this one step, that really takes a lot of time. How much time? Let me show. I was running it before and that was, I guess that picture, let's see. No, that's not the one. So it is, there you are, that's the picture. That's what I was seeing when I was preparing. And so it was 25 seconds, not even done. That's what you usually see when you're training those neural networks. You see those stars, the star means I'm still not finished, and it was continuing. In the end, I got very good precision. So I told this professor who is teaching the next AI course, I said, look, it works. We're using AI. We're much better than the hackers, or at least hopefully we are. And going back to the slides, that's what we've done. Well, how can you do that? That's later on. But he told me a very interesting thing. He said he's working with another guy who investigates the data, not so much what I have done. I've done a mathematical exercise. Can I predict my my data better? Can I predict whether that's a hack or no? And it turns out by now, yes, 99%. He said you didn't get anywhere because the data was skewed in the first place. What you need to do is analyze the data, but protect yourself from the pitfalls. That reminded me of where those hacker wars are now. There is an algorithm that will fool the opposing side and will show it a picture which looks okay to humans. But because it is a well-known algorithm that the other system uses, we will fool it by putting a few pixels in the wrong place, and it will completely mess up what it says. And to a human, it could look like one thing, but to the computer, a completely other thing. So that is the area that he was in at this time. And I didn't get that report. It's interesting. It's very important. He was obviously showing something beyond the pure math, but that we need to go beyond our knowledge of technology, but understand the data. Well, hopefully he'll give me that too, and hopefully we'll be able to automate that as well. That's what people are working on. Here are the tools. So Python, that's what I was using, essentially Python with a few very smart labs, but there are also all of these other libraries that I mentioned. There are libraries on the cloud. So I think the last thing that I will do, and by the way, that's a very powerful Google computer that does it. I think the last thing that I'd like to do is I'll show you where you can play with all of that for free. Here is the Colab. It's a Google site, Colab Research Google. And they give you lots of learning for free. They even give you the hardware on which to run that. They even give you the GPU, where they don't give you this huge computer, the CPU, TensorFlow processing unit. But GPU they do give. And what you could do is you could run this previous lab. Or you can upload. So you can either look at their examples here, or you can upload your own. And the way you would upload your own would be this. We're just going to that same place where I was showing you the labs. Here are the labs. And then let's do that neural network. It should be able to do that. And LSTM stands for Learn Short-Term Memory, which means that we control how much we remember, because forgetting is actually also good for the people. And then now I'm showing that to you not on my computer, but instead it's running on Google's computers. You see that I'm clicking here, it's sending this code to Google over there. That's why it's showing this. And it says using TensorFlow backend. And then we will just continue. Okay, I still do this shift return. I want to run to the training just to see if that works. Now, please note that I uploaded to Google and straight away I expect my lab to work. Let's see if it is faster. For me, it took about a minute. For them, they promise, what, 6 minutes? Probably yes. Okay, so my Mac is 6 times faster, but I'll let them run. So that is the story, and to summarize all of that, it seems like cyber industry is not completely there where I thought they are, but rather it's coming up to speed, and hopefully we'll have more protection against hackers. Now, if you don't want to do all of that and set it up all for your person, for your organization, then of course there are companies, you know, like I got very interested in security by just reading, and then I had wonderful guy. His name is Jeremiah Grossman. Jeremiah Grossman, who came to my city of Houston and who showed real lifetime hacking. So that is the guy who founded the company that was White Hat Security and ran it for a while, then he left there. But he was explaining that you either pay me or you pay them. So that is the story. Well, for example, one of the popular hacks is encrypt your data and never give it back to you unless you pay. And supposedly the good culture is never pay them, always fight. Well, that's what people in the consulting industry would recommend. That's not exactly true. It turns out people quietly pay all the time because they don't want to be in that situation in which hackers put them. So I think that tells you pretty much the story. I want a picture. Pretty much the story. Yeah, that's him. All right, I'll stop the show. And I'll look in the chat to see if anybody had anything to say. Questions and answers, nothing is yet. I did have this chat somewhere, right? Okay. Well, if there are no questions right now, then please do that. Email the questions, right? Please give me your feedback. Tell me if that was interesting. Tell me if that is what you expected and so on. Please be in touch. And thank you very much for coming. Oh, I do see something. This is chat. Okay. All right. Well, thank you. That's awesome. And Len, hi. Thank you very much. Will it be recorded? Yes. Yes, I know that we are recording this. So later on, we'll send you a link to listen to the recording. And you can always get in touch, info@elephantscale.com. All right. Thank you very much. It was a pleasure, and everybody have a good day.